Okay, this is exercise 3.5, function of a function rule. We're going to start this. I'm going to show you this rule by an example, and then we're going to derive the rule. The example is to differentiate 2x plus 3 to the power of 5 with respect to x, okay? And hence find the integral of 10 times 2x plus 3 to the power of 4, and hence find integral of 2x plus 3 to the power of 4. So we're going to start off with this first bit, 1, to differentiate 2x plus 3 to the power of 5. So I've got y equals 2x plus 3 to the power of 5. So therefore y dashed, or dy dx, will be bring the 5 to the front, 2x plus 3 to the power of 4 times, differentiate what's inside, which is 2, and you get 10 bracket 2x plus 3 to the power of 4. So therefore, if this is your original function up here, 2x plus 3 to the power of 5, then if you differentiate it, in other words, the derivative is 10 times 2x plus 3 to the power of 4. Thus, if you integrate this, remember differentiation and integration are reverse processes. So if you differentiate the one with the power of 5, you get this to the power of 4. And if you integrate this, integrate 10 times 2x plus 3 to the power of 4, you'll get 2x plus 3 to the power of 5. So that's part 1, to differentiate it. Part 2 is hence to find. So therefore, the integral of 10 times 2x plus 3 to the power of 4 with respect to x will be this, 2x plus 3 to the power of 5 plus c. And then part 3 says, hence find the integral of 2x plus 3 to the power of 4. So therefore, the integral of 2x plus 3 to the power of 4, we're trying to find that. Now, if you look at part 2, we only know how to find the integral of 10 times 2x plus 3 to the power of 4. So I'm going to say that that is the same as doing 10 times 2x plus 3 to the power of 4. But here I've got an extra 10. This is 10 times bigger than that. So to alleviate that problem, I'll divide by 10. So therefore, this left-hand side expression, 2x plus 3 to the power of 4, is the same as doing 10 times 2x plus 3 to the power of 4 divided by 10, because the 10's cancel to give you that. Now, the reason I'm doing that is, remember, when you're integrating, you can pull constants out to the front. That's the same as doing 1/10 times the integral of 10 times 2x plus 3 to the power of 4. So when you integrate and everything's attached, the constant, that 10, would stay the same. So what I'm doing is I'm bringing that constant out the front. This is 1/10, so I'm bringing that out the front. The reason I'm doing that is because I know how to integrate this. The integral of 10 times 2x plus 3 to the power of 4 is here in part 2. It actually is 2x plus 3 to the power of 5. So I've got 1/10 times 2x plus 3 to the power of 5 plus c. Now, therefore, I'm going to write this as 2x plus 3 to the power of 5 over 10 plus c. Now, we know that when we integrate something like x to the power of 4, for example, if you integrate it, you get x to the power of 5 over 5. So if you integrate this function to the power of 4, you do get that function. You will get that to the power of 5 over 5. Now that's what you're expecting to get, but notice we're getting over 10 here in our answer, and that 10 is the 5 over 5, but this 10 is really 5 times the coefficient of the x, which is 2. So this 10 comes from, again, you would get, if you're integrating this, you'd get 2x plus 3 to the power of 5 over 5, which we've got there. But then to get the 10, you need to times by the coefficient of the 2. Now, it's really important that you learn it as the coefficient of the 2 and not to integrate or differentiate, what's inside. So therefore, the general rule is, and you only need to learn the general rule, so therefore, the integral of ax plus b to the power of n, the rule is that you will do just what you normally do, which is to raise it by 1. So if it's n, it's now n plus 1 over n plus 1. However, on the denominator, you multiply by the coefficient of the x term, which is a. So it's a times n plus 1, and of course we put plus c. So this is the general rule for integrating a function of a function. Okay, integral of ax plus b to the power of n. So it's only for this type. This is not for doing things like integral of x squared plus 3x to the n. It is not for doing those. You cannot do that. We actually don't do that in the 2-unit course. That is a 3-unit integration. So it's only for that type, where it might be stuff like integral of 3x minus 5 to the power of 7 or something. So it has to be in this format, ax plus b to the power of n, for you to do it. Okay, now on to the examples. These are examples from exercise 3.5. Remembering the rule, I'll just write it up the top. The rule to integrate a function of a function is the following. If you're integrating ax plus b to the power of n with respect to x, you get ax plus b raising to the power of 1, like n plus 1, so increasing it by 1. So it's ax plus b to the n plus 1 over n plus 1, but on the bottom you're timesing this n plus 1 by the coefficient of the x. Please, it is the coefficient of the x, not the derivative of what's inside. We will not be asking you questions such as x squared plus 3 to the power of n. That will be part of the 3-unit course. It has to be of this format, ax plus b to the power of n. So the first one, we've just got 3y minus 2 to the power of 8 over 8, and we're timesing the bottom by the coefficient of the y, which is 3. So we've got 3y minus 2 to the 8 over 24 plus c. With the second one, I think it's easier to take that constant out the front, and we get 2 times the integral of 3x plus 1 to the power of negative 4. That way you won't get it confused with your integration process. So you get 2 times 3x plus 1 to the power of negative 3. Remember, a negative 4 plus 1 is negative 3 over negative 3, but timesing by the coefficient of the x, which is 3. So you get negative 2/9 3x plus 1 to the negative 3 plus c. The next question, K. Integrating 1 over 2 bracket 4x minus 5 to the power of 3. That's the same. I'd like to take that half out the front. I'd like to take that half out the front and write it as 4x minus 5 to the power of negative 3 dx. Sorry, I put the half, that equals a half times. Sorry, that was silly. So that way you don't get it confused with the integration process. So put that half as a constant, put it out the front, and write your 4x minus 5 to the 3, bring it up to the numerator and make the power negative 3. So it's a half times, what have I got? 4x minus 5 to the what? Negative 2 over negative 2 over negative 2 times 4. This is a half times that. So what have I got on the, so on my numerator I've got 4x minus 5 to the negative 2, and on the denominator, just be careful, I've still got this half out the front. So on the denominator I've actually got negative 16. It's 2 times negative 2 times 4. The denominator is negative 16. So I did the negative 2 times 4 and I get negative 8, but remember I've got this half out the front. So girls, this is the same. Are you okay with that? Now, that answer needs to be written the way that the question is written. So it's, notice I've got a power of positive 3 on the bottom. I need to bring this down the bottom. I've got negative 1 over 16, 4x minus 5 squared plus c. How are we with that? Because you've got negative 1/16 and this 4x minus 5, I'm going to write it on the denominator with a positive power because the question's written with a positive power. The next one I was going to look at was, I think, L, 1L. And I need to pull that question up, or can someone read it out? What have we got? Just one sec. Okay, this is question 1L. What should I do first? I'm integrating the cubed root of 4x plus 3 dx. I write it in a format that can be integrated. 4x plus 3 to the, that's the cubed root, to the power of what? 1/3. What's the rule? So sorry, and keep the integral sign there because I haven't integrated yet. So keep the integral sign there until you integrate. So now what do I get? 4x plus 3 to the 4 over 3 over 4 over 3 times 4 plus c. So we get 4x plus 3. Now I want to write it the way the question is. Isn't that the cubed root of 4x plus 3 all to the power of 4? It doesn't matter if I put the power of 4 outside there or put the brackets and put it inside. It doesn't matter. Now what's 4/3 times 4? Isn't it 16 on 3? So you're dividing it by 16 on 3, which is what? Timesing by. So I don't need a line there. I decided to write divide by 16 on 3. So what's the answer? 3 over 16 times the cubed root of 4x plus 3. I like to put the power under here actually. Plus c. It looks better, don't you think? Don't like that power on the outside. Yeah. So I'm going to stick that power back inside. It looks nicer. All right, that's that one. All good? You could have put the 16 over 3 down there. I just wrote it there. Okay? Now, next question. Doing another 3 examples. The first one is the integral of 5x plus 2 to the power of 5 dx. What do I do? Rewrite it. 5x plus 2 to the what? 5 on 2. Good. So therefore you get. So keep the integration sign. We're just changing the way it looks. The way the question looks has just been changed. Now we're integrating. We get 5x plus 2 to the 5 on 2 is 2.5. Add 1 to that and you get 3.5, which is 7 on 2 over 7 over 2 times 5 plus c. So what do we get? 35 on 2, which is 2 over 35. So you get 35 over 2, which is 2 over 35, when you divide by 35 over 2. So you get 2 over 35. I need the question to look like it, the answer to look like the question. The 2 means square root 5x plus 2 to the power of what? Plus c. So that's your answer. I've got that. 35 on 2, dividing by 35 on 2 becomes times 2 over 35. And rewriting this on the numerator, it's the square root of 5x plus 2 to the power of 7. That's a 7. Okay, now, oops, that's a little 7, not a big one. Next, okay, definite integrals done the same way. Definite integrals, let's go. Integrate that and what do you get? Square brackets this time because we're substituting 2 and 0. What do you get? 3 minus 2x to the power of? Increase power by 1, increase power by 1, multiply by the coefficient of the x, times it by negative 2. So therefore we've got 3 minus 2x to the power of 6 over negative 12. And we're substituting between the values of 2, we're substituting 2 and then 0. When we substitute 2, girls, just work it out. What's 3 minus 4? What's 3 minus 4? Negative 1 to the power of 6 over negative 12. Take away. When you substitute in 0, you get 3 minus 0. So you get 3 to the power of 6 over negative 12. Please do not forget to put the negative on the denominator for each of those and to put the minus sign in between. So we get 1/12, negative 1/12 plus something else. You can actually just do it plus, I don't know what 3 to the 6 is, but plus 3 to the 6 over 12. That's what you'll get. Well, because minus minus gives you a plus. I have substituted in. I put in the 2 and I got negative 1 to the power. Yeah, but no, because 3 minus 0 is 3. You don't get a 0 here. 3 minus 0 is 3. 3 to the 6. So minus the negative answer, I've just put a plus here straight away just to save you a bit of calculator work. You can actually just do 3 to the power of 6 minus 1, and the answer's all over 12, by the way, if you want. I can't work out 3 to the power of 6 in my head. It's 81 times 9, 729 over 12. And that probably 11, 18, that simplifies. That's divisible by 3.
182 on 3.
Is it on 3? Is that divisible by...
4.
No, it's over 4.
Over 4.
What is it? 1?
How about 60 and 3/4?
What? Oh, improper.
Yeah. 2, 4, wait. 244. 182 on 3. 728.
Is it 728? Who? Oh, because minus 1. Good girls. Which is?
182.
Good girl. Bad girl. Okay, 182 on 3. Oh, we forgot to subtract the 1. But look, you can just do it on the calculator. 182 on 3. And the last one, before you integrate. This is the last question. You make it look different in a form that can be integrated. Let's stick that 2 out the front. You know why? Because I don't want to substitute with the 2 while I'm doing all the substitutions. It gets messy. Bring the 2 to the front. Let's just write this as something with 1 power. What's it going to be? 5x minus 4 to the what? Well, it's 3 on 2 if it's on the bottom. Negative 3 on 2. Because it's 2 over the square root of 2 over 5x minus 4 to the 3 on 2. So I want to put this 2 out the front. You know, putting that 2 out the front saves you including it in your substitutions later. You really don't want to be including it in the substitutions. It's just more work than what you need. Oh, actually, so you know what? Actually, I don't want to write it. Yeah. All right, we have to do it like this to integrate. What do you get? 5x minus 4 to the what? Yeah, because negative 1.5 plus 1 is negative 1/2 over negative 1/2 times it by what? Times it by 5. Let me tell you how many people forget to do that between the values of 4 and 1. Let's make it look nicer before you substitute. So what's negative 5 on 2 will change to, so it's 2 times, negative 5 on 2 changes to negative 2 on 5, doesn't it? Because you're dividing by negative 5 on 2, so therefore you're timesing by negative 2 on 5. Where am I going to write this 5x minus 4? Top or bottom? And how else can I write it? Square root. Now that's a 5. 5x minus 4. Between the values of 4 and 1. What else could I... You know, this 2/5 doesn't need to be part of the substitution. So I'm going to bring that negative 2/5 out to the front. So I've got negative 4 on 5, and I only need to substitute the rest. It's just, look, it's going to give you the same answer. All right, so bring this negative 2/5 out to the front with that other 2, and then do your substituting. You can keep it in, but I wouldn't, because you're just ending up with more numbers that you don't need to be working with, plugging it in twice. Okay? There is no substitution made into the 2 or the 5. So you're going to have 2 over 5 with that first answer minus 2 over 5 with that second answer. It becomes a common factor of both the substitutions, which is why you can pull it out. The only reason I can also pull it out is I've got no pluses or minuses in there. If you've got pluses and minuses, don't pull anything out. So you've got negative 4/5. Now let's substitute. 1 over, now what's the square root of 5 times 4 is 20, minus 4, square root of 16 is, I'll just write it like that, minus 1 over the square root of 1. Because 5 times 1 is 5 minus 4 is 1. So what have I got? Negative 4/5. What's this? A quarter minus 1. It's negative 4/5 times negative 3/4. cancelling the 4s, and you get 3/5. You don't even need your calculator. There is more chance that you'll make an error using the calculator. We're going to do another one of those, and you're going to use your brain, not your calculator. So if you decide not to pull the constant out, you'd have -2/5 square root 16, because if you put the 4 in, you get 20 minus 4 is 16, which is 4, isn't it? Minus, just be very, see how this is actually much worse if you don't pull that -2/5 out. Minus -2/5. Can you see this is really risky doing it this way? So if you don't pull that -2/5 out, you're actually making it really hard for yourself over the square root of 1. And I would not do that. It's much easier to pull it out. And it became very straightforward in here. If you don't pull it out, this is what you've got. 2 times -2 on 5 times 4 is 20, minus negative, which means plus 2/5. Like, this is a lot worse to have to deal with this. That's 2 times -2/20 plus 8/20, making a common denominator. It's 2 times 6 on 20, which is 6 on 10, which is 3/5. Now, I would not go that way. It's much easier to pull this -2/5 out, because look, the -2/5 is there, the -2/5 is there. Why don't we just pull it out as a common factor here at the front? So I want to do another one like that where you're pulling it out. But do you understand why you can pull it out? Because this is all times and divide. There are no pluses or minuses in here. Let's do one more question. Give me a question, someone. I'll find one. Everyone, the homework is exercise 2.5. Every second question, please. 3.5. Exercise 3.5, every second question. So, for example, 1, people want evens here. 1B, D, etc. 2B, D, etc. Okay? Now...